Kind of want to see that.
Just want to show people you're suffering.
We good so far? Let me know if it says image full.
Gotcha.
I hope it doesn't say that halfway through. So this is x between 1 and 2. And I don't have a story for this, what x is and y is, but could be anything. X is how long it takes to cook, what was it? We said the owl that Rich was looking at. And y will be how long it takes to cook that bald eagle. Oh no, we're in trouble now on video. You know? Yep. I'm in trouble there. We don't cook anything, people. Don't come after me, please. I'm vegetarian. I only had 2 cheeseburgers yesterday at Spring Fling. 2 for $2. Couldn't go wrong with them. And my first question, we're going to go through like a stack of questions. My first question, is this a valid density function? Joint density function. So is it a valid joint density function? That's how lazy I am. Is it? Like, it's not much writing there, but I didn't put it there. So that's the first question. Well, we can see if it's a valid density function or not, or what value of k will make it a valid density function. That's probably better that question, because I'm going to make it a valid density function, come high, come low. This will be a valid density function by using the right k. So what should I use for k that will make it a valid density function? Well, to be a valid density function, if you double integrate, I can pull the k outside. X goes from where? 1 to 2. Y goes from what? 4 to 5. X plus y dx dy has to equal to 1. And that will be x squared over 2 plus xy and I have to, from, what is it, 1 to 2, we said x is going to? So I integrate with respect to x, which means y becomes a constant. So when x is 2, that's what? 4 divided by 2, that's a 2, plus 2y, minus when x is 1, that's what? A half, plus y. Two minus a half, is that 3 halves? And 2y minus y is a y, right? And we want that to equal to 1. Let's integrate with respect to y. That would make it what? 3 halves y plus y squared over 2. One equals, when, let's plug in when it's 5, 15 over 2 plus, is that 25 over 2? When x is 4, 12 divided by 2, which is what, 6? 16 divided by 2, which is what, 8? 15 and 25 is 40. 40 divided by 2 will make it what, 20? 20 minus what? What's that number?
14.
14 is 6. So k equals what? 1/6. Remember the problem I stopped by writing 1/6 early? Because I took the problem from the book there. So that's really how they came up with the 1, 6 in the front. When they make these questions, somebody would just say, let's do this. And the only thing that adjusts is make sure that's a valid density function. You can find the value for k to make it a valid density. It's not somebody like an Einstein figure, the limits, wow, that's brilliant. They just work it backward. I could have made this x squared y cubed and go through the whole process and see what k should be. I can pick any value for x from where to where, and the same thing for y. So when we make these questions for the test, I just sit down and go, I'm feeling like I'm going to make this function. This is just ignore the sheet for a second. I go, I'm feeling like I'm going to make it 2x squared plus e to the y. I'll put a k there, and x between what? You pick a number. 12 and 13, yep, that sounds good. Y between what? 0 and 5, yeah, that sounds good. So you work the problem back. We're not going to do this, but that's what we do. Then you make the problem, you work it backward, and you integrate that, and it should give you a value of 1. You can find what k should be. So don't be impressed when you see a problem like this. Oh, wow, they got these numbers working out beautifully. So that's the first question. Is this a valid density function, or what value for k that will make it a valid density function? What else did we do last time? We found that marginal density, right? Probability density. So what was the marginal probability density from last class? When you hear that, that's really f of x, and this is f of, sometimes I call them g when it's y. That's just me. So sometimes you'll hear me say g sub y. When it's the y value, f, I use f for x and g for y. Don't be surprised if you hear me use that. I have a habit of switching them. Not sure where that's stuck in my head. When you say find f of x, that means f of x. Find g sub y, we're talking about this one, which is f of y. And if you remember f as a function of x here, you want to find it. What do? We integrate with respect to what? Respect to y, because you want your answer to be as a function of x, Scott, right? So you want to eliminate all the y's and just leave your answer as a function of x. When you're looking for y, the function as the result as a function of y, you need to get rid of x. You integrate over x. So let's integrate that. I'm going with respect to y. Y is going from where to where for that problem? Was it 4 to 5? 1, 6, x plus y dy. There's the 1, 6. With respect to y, that would be what? xy plus y squared over 2. Y equals 4, 2y equals 5. Was it 5 or 6 I did?
5.
5, okay. When y is 5, that'll be 5 here. Then the minus 4, that'll be 1. I'm just simplifying in my head. When it's this guy here, when y is 5, that's what? 25 over 2 minus what? 16 over 2. Is that 9 over 2? Is it 9 over 2? Yep. So that's what f of x. 1, 6, x plus 9 over 2. This one will be 1 over 6, the integral from where to where? What was x going from? 1 to 2. X plus y, that's with respect to what? X. That'll be x squared over 2 plus xy. X going from 1 to x equals 2. Now, when x is 2, let's look at it. That's 4 divided by 2, which is what? 2 minus a 1/2. That's 3/2. Let's look at the second piece. When x is 2, that's 2y minus the 1y, that's 1y. So it's actually 1/6. I like the y written first. So I found both of these marginal probability density functions. Now, other questions we might ask you. Can you tell me, these are new stuff now, we did that last time. By the way, is the function, the joint density function, is that independent function, is x independent of y? For the function to be independent, or x and y to be independent, so is x independent of y? I'm asking the next question, trying to cover all the stuff we did last time. For the answer to be yes, if what? It's if f of x comma y is equal to f of xx times f of yy. If you can prove that, then they are independent. What is my f of xx? I have it here. 1/6 x plus 9/2. What's f of yy? 1/6 times what? Y plus 3/2. I'll take this little, that's times here. I'll do the square brackets. Will be a better choice here. So it's this one times that one. Does that equal to 1/6 x plus y? Doesn't look like it. I can see already 1/36 here. Are they equal? Doesn't look like it. No, they are not independent. And that's what we did last class. Remember that, everyone? We did the marginal density function f of xx, marginal density function f of yy. Now let's take a look at the conditional distribution. Remember the probability of y given x? We did the conditional, the probability of y given x. We said this is what? The probability of x and y divided by what? The probability of y. That's how you find the probability of y given x, I think, I don't know, maybe 2 months ago. Well, when you have a joint density function, we call these conditional distributions. Again, what we mean by this, can you tell me what is the probability of this happening knowing that x already happened? Like question, what is the probability Donald Trump will win the Republican nominee given, I know Louis not here, given Ted Cruz just chose a VP, his running mate, you know? So we know that happened. We know Ted Cruz yesterday announced he actually selected Fiorina to be his running mate. So what's the chance now of Donald Trump still going to win the election knowing that happened? Probably increase the result. Nobody likes Ted Cruz. He labeled him perfectly, lying Ted, you know? I'll tell you, that guy, I should give him an award for coming up with names. He's even better than me. He gives names to everyone. His name's nothing, and it sticks to you too. God, Louis, I miss Louis today. Yeah. Louis been gone for a while, okay. So we're going to find the probability of y given x. This is the condition. Well, give me some room here to write. The way the book writes them, what's the probability joint density of y knowing x? There I am like this. And just like this. It is actually the joint density function of both of them divided by the marginal density function. This is given x, by the way, not y. It's always the given one. I wrote that wrong. Whatever the given one. The given is x here. So this is divided by f of x of x. And if you want to find f of x given y, I'm just today dyslexic. These guys have to be matching. I don't know why I'm switching. Oh, this is y given x. That's correct, yeah. That's good. So this will be what? F of x comma y divided by what? The given one, which is f of y, y. Knowing that already happened. So for the previous example we just finished doing, so the one we just did here for this question, if you want to find the answer to them, what is f of y given x? We know what f of x and y, it's 1/6 x plus y divided by f of x, which is 1/6 x plus 9 over 2. Clean it. Now what they might do there, they might have fun with you. But you know, with this question, can you tell me what is f of y given x of y given x equals 2? Oh wait, x was between what? 1 and 2, right? Let's use 1.5. Oh. Knowing x is 1.5. What's the answer? You go back to that function, what do you do with it? You replace x with what? 1.2. So that would be 1.2 plus y over 1.2 plus 4.5, right? 1.2 plus y over 5.7. So you tell me what value of y, I'll tell you what the answer is. At that x value. Y between 4 and 5, right? So if you want it when y equals 4, you let y be 4. When y equals 5, you let y be 5. Y equals 4.5, you put in 4.5 there. And we can find also the joint density of f of x given y.
Didn't the probability go over 100%?
Correct. Yep. The probability of any event is between 0 and 1, and the sum of the probability, it's always between, it's always equal to 1. So for example, if I give you this one,
I guess if y was 5, then it would have been over 100%. That's right.
yep, where?
In the equation there.
Yep. So if it's 5, that'll be what, 6.2? That can't be, because there can't be more than 1.
Okay.
That means probably won't reach it there, you know. So let's take an example here. I'm just looking at the back of a book here. I found a book in front of me. I'm looking for examples that we can go through different ones. Okay, this is actually an interesting problem here. Here's what we know. We have a function. Again, this is going back to calculus to make sure your integrations are good. Eight xy, and x and y, here we go, belong to the area A, and 0 otherwise. X and y does not belong to A. What is A? We're talking about this region. From 0 to 1. Uh-oh, there's McDonald. He's going to come here now. You'll see. He'll walk in, look at the board. So you have to be in this region. Love the guy. It's funny as hell. You're in this region. That's the region A. So what's the height here, by the way? Has to be a 1, right? It's y equals to x. When x is 1, y is 1. If I ask you, for example, what is the probability? Scott, you said the probability can't be more than 1. And notice, if you find the area of this, so if you want to find the entire area of that, it's 1/2 the base times the height. It's a triangle, right? So that's less than 1. That's equal to 1. But find the probability of x is greater than 0.5 and y is less than 0.5. If I just graph this mathematically, if I just graph it, y equals to x, this is the 0.5 right here, and let's say this is the 0.5 in the y direction. X is bigger than or equal to 0.5, y is less than 0.5. We're talking about this box right there, aren't we? So I can do I can go integrate that, or I can just look at the picture and say, I know what my answer is. Length times width, which is what, 0.25? And you think you get the right answer. What do you think? Not really. this is you thinking again, just of area here. Double integral here, the definition for that, it's really the double integral from where to where? X going from 0.5 to 1. Y is going from where to where?
0 to 0.5.
Y is going 0 to 0.5. I'll take that. Yep. My function is what? 8xy, 0.5 to 1. That's dx first, dy second. Integrate that, what do we have? With respect to x, that becomes x squared over 2, that's 4x squared y from 0.5 to 1. When x is 1, that's 4. Oh boy. What is that? I need a calculator there. 4 minus 0.25 times 4. Is that a 1? That's 1. So 4y minus 1y, I think that's a 3y. Which will be what? 3y squared over 2. Y goes from 0 to y equals 0.5. When it's 0.5, what do we have? That's a half. 3 over 4, that's 3 over 8, which is what? 0.375. Remember, if you just multiply this together, you go, that's triangle, the area is 1. But if you double integrate that, it better be not 0.5. It should be 1 to be a valid density function. So don't just look at the picture, go, oh, I know what that is, that's a square there. Because if I double integrate that, it should give me a value of 1 if my integration is correct. How would I integrate that? Which way you want to take it? Strips horizontally or vertically? You decide. Vertically? You want to add these little pieces each time?
This method, right?
Yep. Well, you just find the area, yep, using like, so that would be what? To see if it's valid, x is going from 0 to 1. Y is going from where? 0 to, not to 1, to x, right? 8xy. We're doing dy dx.
When you give us problems like this, are you going to give us the area or the...
I might give you a shape, something like this, or say x between 0 and 1, y between 0 and 1, and y equals to x.
Gotcha.
So then you have to draw the picture and see. I might say in the area there. But I'm going to give you something where the limit's not going to be 0 to 1, 0 to 1. You have to think about the integration. Like this one here. Y is going from 0. It's not going all the way to 1. If you go 0 to 1, that means each one of these pieces is going as high as 1. They don't go as high as 1. They only go to that line. So that's where your calculus comes in. So you integrate that, that's what? Y squared divided by 2, that's 4x y squared from y equals 0 to y equals to x. When y is x here, what do we have? 4x cubed, right? Integrate that, what are you going to have? X to the 4th, and x is going from 0 to 1. When x is 1, that's 1 minus 0, which is 1. And that is a valid density function. But if you just find the area of that, 1/2 the base times the height, that's a triangle, you are getting what? 1/2. So don't go by the area there. I'm just saying your function x and y is good in between these numbers. So you still have to integrate that. Now, let's say I want to find the joint density function. I'll do the marginal, the conditional ones. I'll go through the whole thing with it. I just wanted to clarify it's not the area there. Now with double integral. Single integral, that's what we did. The area was single integration. That's one of the application of that integral is you find the area under the curve. So now what is f of x? I missed my coffee this morning. I drank it quickly. So that's with respect to x. I need the function as a function of x. So I need to take y and integrate y. And again, look at the picture. Where's y going from? Does it go from 0 to 1 or 0 to x? 0 to x. And x is going to go from 0 to 1. Notice the x value goes from 0 to 1. But the y value goes from here to that line, 0 to x. So if you plug it in here with respect to y, what are we going to have? 4x y squared. Y goes from 0 to y equals x. That will be what? 4x cubed? And x between 0 and 1. If I want to find f of y again, same thing. Now this will be a bit trickier, the integration. Where are you going from? Let's look at this. Now, you integrate with respect to x, right? So the x value start from the first one from 0 to 1. But the next piece, where you start from? You start like from here. And the next one from here to there. And the next one from here to there. So you're not starting from 0 all the time. You're starting from this x value to 1. But you want your answer as a function of y. So if you go from x to 1, we're in trouble there. Since x equals to y, this will be from y to 1. Because you want to come up with an expression that has y in it. So it starts from here. The next one starts from here to there. From here to there. So from the x value, you can say from x to 1. But if you go from x to 1, you will lose y. And your goal is to get your function as a function of y. Well, since y equals to x, then you put a y in place of it. With respect to x, that would be what? 4x squared y. And x is going from y to x equals to 1. When x is 1, what do you have? 4y. When x is y, what do you have? 4y cubed. And again, y between 0 and 1. What else we did? We did the conditional one. The conditional one is what? It is f of x given y. That's f of x comma y divided by what? F of y of y. The given one is always goes on the bottom. So that should be what? What's f of x given y? 8xy, yep. Divided by f of y, we can factor the 4 out. Two xy. Oh, actually the y can, yep, I can lose the y. If I factor a y out, 1 minus y squared, right? So you end up with what? 2x, 1 minus y squared. Again, if they give me a number for y, I can plug it in and tell you what f of x is going to equal to. And what is f of y given x? Notice, I could actually ask for these two questions. You still got to do the other pieces. If I just ask for these two, sometimes I can be like, it sounds like a nice guy, give me this and give me that. Well, you can't answer this if you don't know what f of y and f of x. So you really got to do it before you can answer that one. And it gets worse, actually, you'll see that. Yep. This is given x, so that's f of x comma y over f of x of x. F of x comma y, which is what? 8xy. F of x, I lost it, I see it, 4x cubed. Simplify that, 2y over x squared. So if they want to give you a value for that again, where's x going? From where to where? 0 to 1, was it? What was x for that problem? I think it was 0 to 1. So we might say, what is f of, I hate the writing, this y given x, I'll do this. Y given x, instead of saying x point, we just go even, here we go, 0.5. That means y given x equals 0.5. So you let x be 0.5 in that expression. That's 0.25, that's 1/4, that's 8y actually. What was that question you asked me about it, Scott? Scott asked me about this. He goes, hey, was it this one? Where was it, Scott? Was it this problem?
It was the one before.
When y equals 5, you said that'll be more than?
Yes.
Okay. What about the question, because I was thinking about it when I was talking about this. Let me just put these in the right order so I don't lose them. Here's what I found on that previous example. In the previous example, Scott didn't like this. And I came up with an answer of x plus y over x plus 9 over 2. I think that's what I came up with. So if I ask you what is f of y given x, y when x equals 1.2, I think that's what we did there. And we came up with what? 1.2 plus y over 5.7. And he goes, well, what's the probability? The probability is more than 1. Let me ask you the question, what's the probability, going back to that problem, that y is less than, the y value going from where to? Is it 4 to 5 for that one? Let's say y, that was 4 to 5. What is the probability y will be less than or equal to? Pick a number between 4 and 5. Any number you want to.
7.
5? You want 5? I'll do 4.7 first because I know where you're going with it, Scott. I know exactly where Scott's going. He wants an answer more than 1. He's not going to get an answer more than 1. I'm going to show him. So I'll do the 4.7. Given x equals 1.2. That's what he's asking. We know when x equals 1.2. Well, the answer to that is not plug it into this one. It is the integral of that function. As y goes from where to where? From 4, and what'd you say to me? 4.7 with respect to y. That would be your answer to get the probability. The function might be more than 1, but not the probability.
Thank you.
Yep. So integrate that. I can take the 1 over 5.7 out. Now I'll come back and I'll put the 5. I should answer at that time for him there. But I was trying to think when I was doing the other problem, what's the best way to approach it? So that would be 1 over 5.7. Integrate that, that's what? 1.2y plus what? Y squared over 2? As y goes from 4 to 4.7. And I'm not sure what that number is, but I am positive if we did the math correctly, my answer is going to be less than 1. Where's the calculator? If we did the math correctly, we should have an answer of less than 1. So here we go. 1.2 times 4.7 plus 1.2 squared, plus 4.7 squared divided by 2 divided by 5.7. At the upper limit was 2.927. Let's look at the lower limit. 1.2 times 4 plus 4 squared, which is 16, divided by 2, that's 8. Divide that by 5.7, 2.246. So let's subtract them. 2.927 minus 2.246. The answer is 0.681. Is that what you got, Trent? You said that early?
Yeah.
Yep. So notice that answer is more than 1. So Scott wanted to know, what happens if you go to 5? Because I know where he was going with that. He wants to know if the answer is going to be more than 1. So let's see. If you go into 5, we're covering all of them. Given x equals 1.2. So that's the integral from 4 to 5 of 1.2 plus y divided by 5.7 dy. So now let's plug it in. With respect to y, let's factor the 1 over 5.7, 1.2y plus y squared from 4 to 5. (1.2 times 5), that's the way to look at it, plus 25, that's a 31, right? Minus 1.2 times 4, plus the 16, 20.8, 31 minus 20.8, divide, that's not right, the number. Let me double check.
I got exactly 1.
Exactly 1? Yeah, should be 1. So I did 1.2 times 5.
You got, it should be y squared over 2.
Oh yes, that's what it was, yeah. I forgot the square over 2. So plus what? 25 divided by 2. 18.5. And that number, because you're covering all of them, has to be a 1. You're going all the way from 0 to 4. You cover every single possibility. When it's 4, 1.2 times 4 plus 4 squared is 16 divided by 2, that's 8. 12.8. So what's 18.5 minus 12.8? 5.7 over 5.7, bingo. So if you're covering all the cases, you're going from the smallest value to the largest value, the area better be a 1.
Thank you.
You're welcome. So f of x and y does not represent the probability. The probability is the integral of that. I should have said that earlier, so it'll be with the notes, but I thought about it after. And I got to go back to that one, make sure we're clear on it. I'll squeeze these 2 sheets of notes between the other ones. I don't know where the other ones are. Or this one here. So I can squeeze. Oh, Mr. McDonald, how are you?
Are you okay?
Yes.
As long as you're okay.